Hello guys. Today in this video we'll be discussing one of the medium level question from LeetCode, that is rotating an image. Now let's understand the problem statement and the constraints given. So in this question it is stated that you have been given a square matrix of size n into n and you have to rotate that matrix into in 90-degree clockwise, right? And you have to do it in place. You don't have to create a new array. So do not allocate. So if you see in the last, do not allocate another 2D matrix and do the rotation. You have to do it on the same matrix so that you save on the space. Now, the constraint that I have been given to you states that the number of rows and number of columns are equal, that is equal to n, and this n can vary from 1 to 20. So you can have maximum of 20 rows and 20 columns. And each value in the matrix can range from minus 1000 to plus 1000. But practically in the logic that we will be writing, we don't care about the value because this would be an integer array, and whatever the value of the integer, we just have to replace it with another value. Now what value it has to come and how that logic has to be driven, that we'll discuss henceforth. Now let's see one example to understand this better. Now I have drawn a matrix of 4 by 4. So where I have 16 elements and you can see them over here, that are 1, 2, 3, 4, 5, 6 and so on. Now rotating this matrix by 90-degree means you have to create this 1, 2, 3, 4, this particular row in the last column. Then the second row would be in the second last column, and henceforth. So this is how you will be rotating the image in 90-degree. Now let's see what approach is the best approach and how to solve this question in minimum time complexity. Now to solve this question, I'll be using a technique where we'll be transposing the matrix and doing a reversal of each and every row. Now how that works is I'll give you a demo and then we'll understand if that approach will actually work. Now let's say that this is my original matrix and I just do a transpose of this matrix. So by transposing this matrix, what I would get is just my rows would be converted into columns and columns would be converted into rows. So it would be 1, 5, 9, 13. I'll write this 13 properly. Then 2, 6, 10, 14, 3, 4, 7, 8, 11, 12, 15 and 16. Now this is my transpose. So on the first step I do a transpose of my original matrix. Now I'm saying that in the second step, reverse each and every row in the transpose matrix. Now let's do that. So first row becomes 13, 9, 5, 1, 14, 10, 6, 2. Sorry, this should be 15, 11, 7, 3, 16, 12, 8 and 4. This is reverse each row. Now if you compare these two matrices, aren't they same or not? So it's just two-step process. So you just have to break the problem into pieces. So here the two pieces of the problem is first transpose the matrix and then do a reverse of each and every row. That would finally result in your 90-degree rotation. Now, if you want to do a 180-degree rotation, then I would suggest do this step and then go ahead and do this same process again. But if there is another approach to it, that's not what we want to discuss right now in this question, but let's keep it to a 90-degree rotation for now. Now let's write an algorithm for this, and then we'll write a code for this as well. Now, as the question states that you have to do in place rotation, that means you don't have to create another matrix. That means the last video or the video that we have already done to transpose a matrix will not be relevant in this scenario, because there we were creating altogether a new array. Now, how to do a in-place transpose? Now, to keep in mind, in-place transpose of an matrix can only happen for a square matrix. It cannot happen for a non-square matrix, that is a rectangular matrix, because in that the number of rows is different from number of columns, so the resultant matrix will have a different shape. But for a square matrix, the shape remains same. That is why in place matrix can be done. Okay. Now, by in place matrix, in place transpose, there is a catch, and I want to explain you that part in detail so that the algorithm that we explain is easily understandable and we can write the code easily. Now, for the first time, when you think of transposing the matrix, you think of it like being I would change the value of I comma j to j comma I. That's true. Let's start doing it and understand if there is a flaw in that scenario. So this is my 0 comma 0. So for my 0 comma 0, I'll write all the possible indexes first, and then we'll try to figure out what is the error in that. Uh, okay, till here. Then I'll write next indexes over here for next two rows. Let's say for I is equal to 2, j 0, 2, 1, 2, 2, and 2, 3, and so on. So by this time you'll be very clear of what I mean to say. So let's start doing it. Let me take this. So for I 0 0, that means for element 0 0, it will be same in the transpose matrix because I and j are same, right? Now for I 0 comma 1, that means 0 comma 1 is this would be converted into I 1 comma 0. That is correct. Now you have to keep in mind that we are doing a swap. So what I'll do is let me do one thing. We can do the swapping in the original array instead of doing it in this array. So what I'll do is we are actually swapping the elements from I comma j and j comma I. So we'll be interchanging these two elements, right? So that is the basic logic. So for I0 j1, I would be changing that value, this value, with I and j, I as 1, j as 0, right? So that means 5 and 2 would be interchanged. So let's interchange 5 and 2. So my 5 goes over here and 2 goes over here. Okay, so practically I'll write these with let's say some other pen, red pen, so that it is very clear that these are already done. Okay, so this is 1, 5 and 2. Okay, now we are on index 0 comma 2. 0 comma 2 means this would be interchanged with 2 comma 0, right? So 0 comma 2 with 2 comma 0. So 3 and 9 would be interchanged. So let's move 3 over here and 9 over here. Now let's do it for 0 comma 3. So 0 comma 3 would be interchanged with 3 comma 0. So 4 and 13 would be changed. So 4 would be coming over here and 13 would be coming over here. Now for next row, so that means 1 comma 0. Now 1 comma 0 means this value, and this value should be interchanged with 0 comma 1, right? So practically what you will be doing is you would be interchanging these two values again to their original positions. Understood? And this would happen with your complete matrix. So if you do it for all values for I starting from 0 to n and j starting from 0 to n, practically n minus 1. So if you do it, you would end up in getting the exactly same matrix that you were given. Now what is the solution? Now the solution is very simple. Let me go back to the original matrix and then we'll figure out what is the solution. One, two, three, 4, 5, 9 and 13. Now the solution is simple. What I'll do is I would take either the first half of the triangle and swap it with the other half. So I would only take indexes that fall either in this part of the array or this part of the array. So either the indexes should fall in this part of the array or these should fall in this part of the array. So if I do that, then this will not happen. So if I do that, let's take so for me, I would take lower triangle and I'll swipe it with the upper triangle. So let's remove everything from here. This all goes down, this goes up, this is also gone, this is also gone. Okay, so what I'll do is I'll do nothing, but I'll just say that my I can go from 0 to n minus 1, but my j will only go up till I. That means I is my number of rows and j is my column. So that means if I is 0, then my j can be max up to I. Or practically I don't care about the ith element, because if I say I and j equal, this is the diagonal, and in the transposed array, if you see, the diagonals are always same. So why do I care about transposing or doing anything to the diagonal elements? So what I'll do is I'll mark my condition saying that my I should go from 0 to n minus 1, but j should go from 0 to I minus 1. So that means my I would go from 0, 1, 2, 3, but my j would go only for 0 or 0 and 1. So for this I is equal to 2, over here it would only go for 0 and 1, not 2. So it will not swap this diagonal, but only swap the values below the diagonals with the upper diagonal. Now let's see this in actual example, and let's do it. So let me remove these lines, red lines practically, so that it's easier. Okay. So let me write the indexes for you. So if I is 0, j will not go anywhere, because I minus 1 is minus 1. So j cannot run. So j loop would not run. So for I is equal to 1, my j would run for 0. For I is equal to 1, j would not run for this part. So that means only one iteration for I is equal to 1. For I is equal to 2, my j would be 0. For I is equal to 2, again j can be 1. For I is equal to 3, 1, 2. Sorry, 0, 1 and 2. So my for 3. So this is how this will be. So this is my j. Now let's see what values it will interchange, and let's interchange those values as well. So for I 0, so there would be no change. So we'll do nothing because this is a element on the diagonal. So we'll do nothing on for this. Now for 1 comma 0. So 1 comma 0 should be swapped with 0 comma 1, right? So let's do that. So this is 1 comma 0 will be swapped with 0 comma 1. So my 2 would come here and my 5 would go here. Now my next swapping would be 2 comma 0. 2 comma 0 would be swapped with 0 comma 2. Let's do that. So 2 comma 0. 2 comma 0 is this part, will be swapped with 0 comma 2. So my 3 would come over here and 9 would go over here. Now my next swap is 2 comma 1. Now 2 comma 1 means it would be swapped with 1 comma 2. So let's swap 2 comma 1 this part with 1 comma 2 this part. So over here this would be resulting in 7 over here and 10 over here. Okay, now my next swap would be 3 comma 0 with 0 comma 3. So 3 comma 0 is this part. 13 would be swapped with 4. So this is 13 would be swapped with 4. Now my next swap is 3 comma 1. So it would be swapped with 1 comma 3. So let's swap this. So 1 comma 3. So 3 comma 1 is 14 would be swapped with 1 comma 3. So that is 14 and 8. So 14 would come over here and 8 would come over here. Now my next swap is this one. So this one is 3 comma 2. So 3 comma 2 would be swapped with 2 comma 3. So if you see 15 and 12 would be swapped. So my 15 my 15 comes over here and my 12 comes over here. Now if you compare this with the transposed matrix that we had earlier, this one, so if you compare these two matrices, they are same. So over here if you see, my iterations are almost half if I have a square matrix as compared to a rectangular matrix where we had to actually run through all the elements, that is n into m. Over here the time complexity is still n square, but your actual iterations are n square by 2. But divide by 2 is of no use because we don't consider the constant values. So that is why it remains n square, but your actual iterations becomes half. So time complexity of transpose becomes big of n square. And space complexity, because we have been mentioned that we have to do inline, so space complexity in place transpose and everything. So my space complexity is 1. So this is how we'll do transpose. And for reverse, we would just keep swapping these values for each and every row. So that is again my n square. So for reverse also my time complexity would be n square, because we would be visiting each and every element practically. So that would be again n square. That would be n square by 2 because you would just visit half of the matrix again. But n square divided by 2 is equivalent to time complexity n square, and space complexity is again big O of 1. So I'll write the time complexity bit clearer. so that it is clear. So my total time complexity becomes big O of n square plus big O of n square. So that is equivalent to big O of 2n square, which is similar to big O of n square. So the complexity becomes big O of n square. So this is the complexity. Now let's jump to the algorithm part of it, and then let's see the code for this. Hope you guys are understanding the algorithm, or you are liking the way I am explaining the question. So please do not forget to like, share and subscribe to our YouTube channel so that it keeps us motivated, and also comment down below in case you want us to solve any particular question from LeetCode. Now this is the algorithm that I have written over here. So the algorithm has two major steps. So first step is transposing the matrix, and the second step is reversing each row in the matrix. That's it. So for the first step, what you do is, for the first step, you have two loops. One is running from I0 to n, and second loop running from 0 to n minus, I minus 1. And you would swap ARR of I comma j with ARR of j comma I. So you would just swap these two values, and that's it. So this is how you would achieve your transposing of matrix, and then you would start swapping the each row of your matrix. Now reversing the each row is practically equivalent to reversing a 1D array. So that's very simple logic. Let's see that in code and understand. So the code that I have written is in Golang, but feel free to write that code in any language of your choice, because only thing that matters is this algorithm, and if you understand this algorithm, it would be easy for you to write it in any language that you want. Now this is the code that I have written in Golang. Now if you remember, in our algorithm we just had two steps. Step 1 was transposing the matrix, and step 2 was reversing each row. Okay, so over here in the main function that they have given, I have just written two lines for each step. So the first line is transposing the matrix, and second is reversing each row of my 2D array. So that's it, and this result gives me the matrix back, and we are done. So I could have practically used a pointer to do it. I didn't have to return the matrix, but it is simpler if I don't use pointer, because using pointer is a bit tough for people to understand on the first place. So let's keep it simple and just return the same matrix back. I'll not create new matrix in this example. So the transport part. So if you see, this is my step one. Step one, and in step one, if you see, we have two loops running: for loop which run from 0 to n, and my j loop which runs from 0 to I. And 0 to I, that means less than I means it would run for till I minus 1. It would not go up till I, because if it goes to I, that means it is on the diagonal, and we don't want to swap diagonal with the same element, because practically swapping the diagonal is getting back to its original position. So it's useless doing that swap. Now, what in Golang, it's easier to write a swap logic without using a third variable. But in other languages like .NET and Java or Python, those languages, you might need another third variable to store the value temporarily and then swap. So it's up to you. It's up to your language how you do it, the swapping part. But over here, if you see, my I comma j is swapped with j comma I, and my j comma I is swapped with I comma j. So it's just swapping the I comma j with j comma I. So this is the transpose part. So I have transposed my complete matrix, and I have returned that same matrix again. So this is the in place transpose only. So it does not matter that of the space complexity. So I've written the same matrix over here. Now same matrix I have passed to my another function which is responsible for reversing each row of my 2D array. So this receives the array, And over here, if you see for each row, so this is the number of rows that we have n, and for each row I would be calling the reverse 1D array. So reverse 1D array is simple logic where you just have a 1D array and you just reverse all the elements from the 1D array. So this is that same logic and we are calling it for particular row. So I'm just passing that particular row and getting that particular row back. Here also we could have used pointers, but I was trying to avoid pointers so that it is easier to understand. And after it runs for the complete rows, then I'll return the array again to this, and then in place rotation 90-degree rotation is done. But if you see the reverse of 1D array, it is practically I would start from 0 and j would start from the last element of my array, and my last element and my first element are swapped. Then I'll increase my I value to +1 and I'll decrease my j value to -1. So now these two values are swapped. Then again this increment and decrement of I and j happens, and then swiping. So this is happening till my I is lesser than j. Once my I is trying to cross j, that means I would again end up in getting the complete array back to its original state. So I don't want to do that. So that is why I'm just doing it for half. So practically if I have, let's say 3 elements, 1, 2 and 3, so I is 0, j is 2. So this is swapped. When I is then increment and j is decrement, so I becomes 1 and j becomes 1. So these are again, this is swapped with itself. So that is okay. But then I increases to value 2 and j decreases to value 0. That is again, if I swap these two back, so I would get original array. So that is why I don't want that. So that is why I wrote this condition. So this is important. So this is the code that is written in Golang, but practically this can be written as it is in any language of your choice, that is C#, .NET, Java or Python, JavaScript, any language that you wish, and you can go ahead and do it in any language. And if you have troubles with any of the part, understanding any of the part, you can comment down below. We would be happy to help you in understanding the logic better. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from LeetCode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.